Right, are we on? Yes, right, we're live. Welcome everybody, and welcome to the Nature Safe webinar. And have we got a night for you? God, we've got action packed. This has been taking weeks in the making, and we really have got a fantastic evening. So thank you. We've got so many people joining us tonight. Over 200, well over 200, even 200, nearly 250 people joining us tonight from all over the world. We've got the Lagos Islands, America, Canada, Brazil, New Zealand, Germany, Portugal already. So we're really looking for
Mexico
as well. So yeah, we're going to be around for quite some time. Grab a glass of wine, sit down and enjoy. I have to apologize straight away. Any Traitors fans out there? It starts at 8 o'clock. You're going to have to catch it up. I'm a big Traitors fan, but the Welsh lady's gone out now, so we all knew that, didn't we? So anyway, just to introduce our amazing team, we have Debbie, our COO. We've got a star line of people tonight, and going to introduce. We've got Lucy next door as well, who's going to show you how we process the cells. Now we look after the cells. She very much works closely with Nature Safe as well. We've got Lucy known as well as you're going to see a live sample being processed. How cool is that? Also, you got Matt. Matt's a trustee of the charity and also works for IMT International, and he's going to show you how we barcode these samples and how important it is actually to secure these samples, and he's going to go through the whole back on the database. We got Stevie Shepherd from Jimmy's Farm. He's one of our trustees of the charity, and he's going to come live on talk about the zoo side of things, which is going to be fantastic. We've got Kit. Kit's a vet at Tyndale Vets, and he's going to talk about other ways we can collect semen from these endangered species as well, and doing repro checks. It's been incredible what he can do now, and he's going to show you some of the work he's doing. I promise you, you will find it fascinating. Just a bit of a word of warning: if you're having your tea and you're eating it, there may be a little bit of flesh or a little bit of stuff that might put you off your tea, and some other stuff that you might see. So just hold fire on that. Also, we got Lydia behind the scenes, who is doing all the graphics and the videos and all the templates and everything else. So thank you, Lydia. And we've got Lauren there as well. So all right. We've got Sarah behind camera, who's gonna be making sure that everything's been filmed in the right way. We've got Alice over here. It's going to get the questions. So get those questions coming in. The first one I want to ask: let us know where you're from. We had nearly 30 different countries last time we did a webinar. Let's see if we can beat that tonight, eh? Switzerland.
Yeah.
Oh, Ollie's just been there skiing. So I think we've got New Zealand. And yeah, coming on to Grania now. And Grania is our zoo liaison officer. I forgot to say, Alice is our research and media and anything else. Part of Nature Safe. I'm terrible at the moment. But Grania, our zoo liaison officer. So I know we've got a lot of zoos on board tonight, which is great. And they may well have been talking to Grania over time. And also, we can't forget Pam in the lab. She's our sperm queen or goddess. And there's nothing she doesn't know when it comes to freezing and collecting the semen and getting the semen on that side. So action pack, that's just some of the people that we've got here tonight coming up. But it's incredible. We thought we might only get maybe 50 or 100. We've doubled that. So amazing. Thank you so much for taking part on that. So be sure to stay till the end, because we have a prize. We have a giveaway, as always, when we do this. And it is giving 2 tickets exclusively. Oh, thank you, Debbie. I thought and actually, you might want to put the slide up as well. We've got an amazing, we're showing the film called Rhino by Tom Hardy's narrating.
He is narrating. Yeah.
We're
going to try getting him here.
Yeah. We're great in that one. I think we might be sold out. Yeah. But I mean, if any of you are interested in that, what's the date on that? I can't really remember.
18th of February.
18th of February. We've only got 100 spaces. So if you want to, it's going to be a fun night, film night, and that's here. So if you click on the QR code or send us a message and send some information. I presume it's on the website, Alice?
It's on the website.
On the website now. Went live today. didn't it?
Yes.
Yes. So got those tickets going. You want to come?
No, Alice.
We have some more countries tuning in. We've got Ireland, Scotland, Poland, Austria, Romania, and Italy.
Incredible. Oh, incredible. Welcome, everybody.
Good on you Scots out there. Yeah. And anyway, the next one is a skydive motion. We are actually, a lot of you may know, I love chucking myself out of a plane. Actually, Debbie did one last year.
I did.
And actually, Stevie, who's there and behind, he managed to do it. So if you would like to do it, we're going to do it even bigger, even better next year. We had 20 of us
this year.
This year. Last year, 20 of us last year. And this year, we're hopefully going to get up to 50, 60 or 70. So if you're interested, we're going to poll up later and you can express some interest and we will send you the pack. So really, I'm going to hand over to Debbie. She's going to tell you about this amazing charity. Tonight, it's all about Nature Safe, the work it's doing behind the scenes. We're going to follow the experience of a package right the way through. So you can follow the journey of when a sample arrives, how it goes through and how it ends up in our freezers. But before that, I think it's really important for you to get an understanding what this charity is about. And I'm going to leave it over to the COO of the charity, Debbie Romanis. Tell us what is so amazing about this charity.
Thank you very much. Thanks, Alice. I think Alice is just before I speak. Alice has a wee question. Or...
Yes, some people are asking if we'll be recording the webinar, and we are. So we'll have that available to watch the full thing if you can't stay for the whole evening.
Perfect. Thanks, Alice. So what is Nature Safe? So in Nature Safe, we are a wildlife conservation charity, and we are focusing on protecting our wildlife both now and into the future. So how do we do that? We do this through a specialized process known as cryopreservation, which means we store cells from animals at ultra low temperatures, which keeps them alive for an indefinite period of time, which is incredible science. We've got a phenomenal team who you're going to meet tonight and take you through exactly how that process works. So historically, when an animal passes away, we lose that vital genetic legacy of that individual, which obviously contributes to species and populations. But now we can safeguard and preserve that DNA. So potentially in the future, if we need to, we can use that to create new life and help to prevent unnecessary extinctions. We're losing wildlife at an unprecedented rate and largely due to human activity. So we feel it's our duty of care that we can intervene and provide these tools and techniques to preserve wildlife on our planet. So we have a very bold ambition. We are a small but mighty team, I like to say, and we have a bold ambition of trying to preserve species across all species, so from the very, very smallest up to the biggest. And you'll see our cryo stores later in tonight. But we've got snails and spiders and birds and fish, all the way up to your biggest mammals and the most charismatic species that we know. We want to do this because ecosystems only thrive with all the wildlife and creatures within it. So for us to feel like we're doing something really meaningful and impactful, we want to preserve the entire range of species on our planet. So massive ambition, yes, and we are only just beginning, but you'll see later what we're up to.
Wow, brilliant, Debbie. Honestly, we've been doing this charity for 5 years now. And I'm just incredible how it just grows and grows. And Debbie, come in a little bit, and how it's growing so well. And it's just fascinating. And tonight, obviously, we're going to give you a bit of an insight. Just a few other people have joined on. Catherine, or one of our trustees from Shrewsbury, greatly joined on. And also Terry. Let me guess what you're drinking tonight. Will it be champagne? Will it maybe pink bubbly? I think that's what it might well be. Yes, or gin. Yes. So great. But I've seen somebody from Brazil. Obviously, the list of countries now has gone off the scale. So
Serbia,
right?
Welcome.
Okay. So it is great. It really, honestly, for us doing these webinars, it's fantastic to see all the people that are tuning in and obviously the interaction. So keep those questions coming in, and through the night we'll start asking them a bit later. Anyway, we've got a busy night ahead.
I've got one poll question, actually, which I probably should have done before I spoke. But anyway, I just want to gauge so based on your current knowledge, which for some of you will be very early days at the moment about Nature Safe, but if you can, based on your current knowledge, how relevant do you think Nature Safe is to preserving biodiversity? And we've got 4 options, so you can choose not useful, sounds interesting, but maybe not that relevant, it has very good potential, or number 4, you think it's highly relevant and essential to preserving biodiversity. So just pop your answers on that poll, that would be great.
Pop in a postcard and send them.
Postcard.
Right. Believe it or not, guess what we have here? We have a sample here that's arrived, and we're going to just show you this journey. So we're going to take it into one of the first labs, and when the zoos send us these samples, when an animal sadly passes away, they literally it could not be easy, and that's what we're trying to get across tonight, how easy this process is to get it to us and for us to process it. So let's get into the next lab, Debbie, and to show the next team. I'm not normally allowed in here. I get sort of so that Lucy's very strict on who goes in and out of this lab. So yeah, hopefully I should be allowed to. I know, yes, I always get kicked out. So anyway, this is because it's a very well. Lucy explain in a minute why it's so important to be biosecure. Yeah. So this is Lucy. Just go around the room. We've got Matt here, and we've got another Lucy who's working behind the scenes. And Lucy's been fantastic behind that. She works with Gemini Genetics and Sally and AI, but it's really been fantastic, really, with Nature Safe. She's quite often the one, as well as obviously Alice and a few others, that handle these samples, but it's very much been an integral part. And runs our scientific committee, don't you?
Yeah.
Yeah. So
yeah, currently lab manager for Nature Safe and chair of the scientific committee. But yeah, there is a wider team around me as well. Charlotte and Lydia, who can't be here this evening as well.
And I think we've got to get really across. Nature Safe can only do this work with our scientific background, because that really enables us to process these samples in a way that can be future-proof. And Lucy's going to go through this now, Lucy, and show the importance of what you do. So this package has arrived. I'm really going to sort of pass it over to you, Lucy, and really follow this journey on this side of things. So, I mean, I've got a question for you straight away, really. When an animal dies, how long have we got for, if it's a tissue sample, for when the animal dies to get into us to process it? Do we have to do it really quickly, or how quickly does it take?
Yeah, so it depends on what sample you're sending to us. So if you're sending a sample to Nature Safe, you're either going to be sending skin tissue or somatic samples, or you're going to be sending reproductive samples, so ovaries and testes. If they're reproductive samples, if you're wanting semen harvest, that needs to ideally come same day. But we can try our best with overnight postage. Reproductive material in terms of testes and ovaries for preservation of those organs, they can be posted out for overnight delivery. But skin, which is the principal sample that we preserve here in this laboratory, that has up to 5 days after an animal's passed away. So that gives a lot more accessibility to our partners in sending resources to us, because there's not an immediate time pressure in them getting to us.
Right, let's open up the box, see what we have in here.
So this is the way the samples come to us. So we supply the chill boxes for getting them to us. And in this box here, we have a small skin sample. And alongside it comes its paperwork, which for this purposes of the webinar, we haven't got any private details on here. So it is just a blank form, but just to show you that they come with a submission form where we ask you to fill out details related to the animal. And then there's also a health advisory, and we supply guidance obviously on how you take the samples and package them to get to us. Skin samples are the most common sample type that comes to us, and it's most likely related to the fact that you do have the 5 days after an animal's passed away to get them to us. And the first step that we do once they come to us here is to wash and prepare them for preservation. So we can take the camera, if you're okay with that, over to the other Lucy, who's kindly doing a demonstration for us. So she's just got a demonstration piece of skin there under the hood, and we wash it through a series of different wash solutions. The main risk to sample viability in terms of skin and somatic samples is having bacterial contamination on those samples. So the more that partners can clean and shave the area prior to sending the sample to us, the better. But we do further washing of it when it comes to us.
See, we've got it under a hood here.
Yes.
Is it really important we do it in this sort of conditions, or can we do it without a hood, or what's the?
So it must be done under a biological safety cabinet. You can also see that Lucy's got her full PPE on as well.
And the reason for that?
That is to protect the sample from contamination and also to protect the person processing that sample as well.
So we're right in saying when these samples come in, you're hopefully eventually going to grow stuff, but obviously if this stage isn't done right, that's going to affect the sample right way through. Is that right? Or?
Yes, definitely. We need to make sure it's as clean as possible, because otherwise when we come to grow those cells later on, other things are going to grow in there which we don't want. And also obviously these samples are going into the bank to be preserved, so we must make sure that's done correctly, because they're not necessarily going to be woken up, so to speak, straight away. So we need to be making sure they're preserved correctly for future use.
They're a bit tough, some of these, aren't they, Lucy? Because obviously, and you may have covered this, but what's the main sample you tend to get? What part of the body do you tend to get in when you?
Yeah, so I did mention it before. So the main sample type is skin, and mainly from the ear for those that have ears. We do also process ovaries and testes in this laboratory as well. They're just preserving the parts of the ovaries and testes for future regeneration. The semen extraction part, that takes place in the lab that you're going to visit next.
You have to chop them in tiny little pieces, don't you?
Yes, and then Lucy is placing them in one of the cryovials. Because that helps with better. So in the cryovial we have our solution which helps protect and preserve the sample. If they're smaller pieces, then it allows for better penetration of the solution.
And when you're putting it into the vials, do you just put it in one vial, or do you put it in a number of vials when you get a sample in?
No, we so size permitting, obviously, if it's a very small sample that's sent to us, that might be a limit, but ideally we're wanting to preserve 10 vials from an animal, and then we actually have store them across 2 separate storage vessels. So that's our aim per animal, is 10 vials.
We've just had a question come in, and Alice, what was the question again? It was
what is the smallest size of a creature that can be preserved, and what would you take from it? And is it harder to preserve animals that are much larger in size?
So I think the question was, what's the smallest one, and is it easier for the larger?
Yeah. Well, the smallest is a good one. We will always, if you've got a really small sample, we will preserve it in the best way possible. The guidelines that we provide is the smallest area of skin ideally is 2 by 2 centimeters is what we would really like to be able to get that 10 vials preserved for you. But if you've got less than that, then send that to us and we will preserve it in the best way possible. Larger animals, yeah, we don't really need more than 2 by 2 centimeters. That gives us plenty to be banking down, because if there are living cells within the sample that you've sent to us, then that will be more than enough resource. You actually only need a small sample size once it's got living cells in it, because those cells, I can talk about it in a minute, but they can be grown up further in number.
Brilliant. Okay. And then the next stage, so we've chopped it up and
yes, so Lucy's doing the first stage of just preserving the sample so that the skin in whole format can be kept for as long as needed. The second stage is the cell culture, which I can't really demonstrate all of that to you this evening because it's quite a lengthy process. So instead I have an image on the microscope screen here of some cells that we have in culture at the moment. This is just our microscope allows us to freeze the image on the screen and place the cells back in the incubator. So this flask that I've got here is just a demonstration flask. It hasn't actually got a sample in, but it's the same as what we use. So the cell culture is basically about growing living cells from the sample that you sent to us. And this little dish here has little attachments at the bottom that the living cells, if they're there and present, attach to and grow.
I presume this is proof of concept, Lucy, because obviously we can freeze all the samples down, but we want to make sure those samples are live. Yeah. And the only way we can do that, if I'm saying is correct, is to actually do this process.
Yes. Yeah, you need to test that there's living cells present within those samples. So that's what we're doing by the cell culture. So although this is a static image, these cells are living in the incubators that I've got over there. These are fibroblast cells on here, and they contain the whole genetic profile of the animal. and that's what can be used for different conservation tools in the future.
This is the absolute critical part to me, because the samples come in and obviously all the DNA is in here, is that right?
Yes.
Yeah.
So you could use the sample for lots of different technologies potentially in the future.
Wow. I mean, it was astounding. Obviously, we've been doing this for years, but it still amazes me how this. And we've got an amazing story to tell this summer. I think it must have been 2019. There was a southern white rhino that sadly passed away, wasn't there?
Yeah.
And tell us what happened there, because I feel we froze it down in 2019, just the year, and then this year you thought it out, didn't you? And
yes, yeah, and grew the cells, and the rhino potentially being a bit more trickier because of the thickness of the skin, but yeah, we successfully grew the cells, and we've done lots of cell cultures for Nature Safe now, across lots of different species, and they're all. I get very protective over my cell cultures, as Tullis has already alluded to.
I got told off once. She even got a little camera here somewhere. Yeah. And she caught me. Yeah, what's she mean, Rhona? Yeah. But rightly or wrongly, I came here one day, did get told off. But anyway, in there, you had a rhino growing in there, and you had about 2 or 3 other species. It was incredible what goes on in this lab.
Yeah. Very precious, and it's very much a privilege to be part of that journey, to watch something that you've preserved several years ago, actually, when you thaw it out, and then it can come back to life in front of you. And we're growing them over at least a 7 to 10 day period, so that's us very much being hands-on, nurturing them through the process. So they start as little pinpricks in the dish, and then we're growing them up into full dishes full of cells.
And I think maybe this is a poignant time to ask the question, is that we're a living biobank. What you're doing, what's the difference between that and a lot of there's lots of biobanks all around the world? Why are we different?
Yeah, so we're different because we're storing the samples in a way that you can create the living cells from them. There are other biobanks in the world, and their work is still very useful. Their samples, you can't necessarily generate living cells from them. You can still read the genetic information from them, but our difference basically is that our samples are preserved so that you can create this new life essentially in the future with a different technology.
We might talk about this later, because there is a lot of confusion. There always is, between dead biobanks and living biobanks, and we're actually living biobanks. So all our cells effectively are still alive.
Yeah.
Yeah, and the DNA.
Yeah. But both biobanks are very important. But yeah, that's the difference. Is the living biobank, the cells have the living ability, but still there is still the importance of the other biobanks out there as well.
And after this stage, that's it, you freeze it back down again?
Yes, after this stage, the cells can be lifted from the dish, and they're preserved back down in the cryo, and then they go back into storage.
At what temperature?
-196.
Yeah, so it's pretty cold.
Yes, and one of the, well, I get a common question, but I don't know whether I should ask it. But lots of people say, well, why can't we freeze the sample if you're freezing it at the end of the day when it's with you? And that's because we are doing all this process beforehand and preserving it in a special solution that protects it. If you just put it straight in the freezer, you will rupture the cells that are there, and they won't be able to be living as they are now. So that's the difference.
And we might talk about that when we go to the freezer room as well. But once you've done all this work, the next bit, there's no point having all these cells frozen if you don't know where they are, who they are, where they're stored, and all that. And we looked for a long time at what the best system is, and we're very lucky. This is Matt Pettit from IMT.
Hi.
And you've been working, well, we've known each other for, I feel like, a long time now. 30 odd years now. But you've always been into cryo work, and I know looking at how you can freeze cells down and bring them back, sperm cells. But you work on the human IVF side quite a bit.
I come from the sort of commercial animal breeding industry, so I have a background in animal breeding. In the last 20 years, I've also been working within the human sector, where it's a slightly different prospect. That's not for preservation of tissues and cells. It's more in the spirit of the treatment of infertility. But actually, a lot of the working practices are very similar, and it's going to be really interesting to show you the rest of that journey as the samples progress through the journey from here, the point of entry, where Lucy and Lucy are preparing the samples, ready for that journey moving forward, I think it will become apparent to the audience that there is actually quite a lot to that, and it is quite high tech.
And your system that you use, I mean, because obviously it is absolutely critical. There's no point just doing all this work if we can't data. So can you explain a bit about your system and how it works? I think you got some demos or something. Yeah.
Before we sort of illustrated, it's probably important to recognize that when we think about biobanks, we're talking a lot about the biobank, the living biobank. It's tempting really just to focus on the cool stuff, the precise dissection, the processing of the tissues of the cells, all of the high-tech machinery that's used that you'll witness as this journey goes on. All the way through to cryopreservation. And as we get closer to cryopreservation and long-term storage, then what happens to those samples within storage and even beyond when it's time to regenerate those samples. But it's also really important to note that behind the scenes, there also has to be, it's absolutely imperative that there is a system in place which is very similar to any high stakes financial institution, so a different type of bank. So just like a bank that is storing money, the money is their financial asset. In a biobank, it's actually the samples. If you could pass me one of the tubes, tell us what the samples that are being stored, these are our assets. These are the biological assets. These samples store the blueprint or the DNA from the individual species and also from the individual animal from where it came from. So just like in a real bank, it's very tempting just to focus on the vault. But actually, most of the real critical work takes place in the ledger. It's what's happening before the samples end up in storage. In a real bank, you wouldn't just throw your money into a big pile. In the same way that in a biobank, we don't just store the samples. We need to track those samples. So every time there is a processing step, every time a sample is dissected or it's processed for cell culture or it's moved into cryopreservation, that's effectively a transaction. And those transactions need to be tracked. They need to be traced in exactly the same way that a real bank would operate. And that's what we've been really careful to develop here at Nature's Safe. Right from the get-go, before the laboratory was even established, we established that digital chain of custody so that we can track those samples from the point of collection all the way through cryopreservation and even beyond. We've got to bear in mind that there will be, well, there already are literally thousands of biological samples all being stored under liquid nitrogen, and they may be there for decades. So we need to be able to keep a track of those. So in able to maintain that chain of custody, firstly, we introduced a labeling system that uses barcodes. So barcodes may seem simple, but they're actually extremely sophisticated ways of being able to create a digital footprint for each of the samples that's being stored. So even before the sample arrives here in the laboratory, the animal has been registered within the Matcher database, which is the system that we've developed that we're using and has been configured for Nature's Safe. Those animals have a globally unique serial number, which will be used to identify the individuals. And then each and every label can also be uniquely identifiable down to the sample. So those samples, once they're stored, will contain not only the name of the animal, the type of tissue, the date and time that it was collected, a lot of the history of the animal, but there's also a digital footprint that's created. And then using scanning devices, we can then catalog those samples. So we can track those globally unique samples through the database, and we can keep an auditable trace of those samples. So that digital chain of custody then gives us the ability to be able to recall the information. So there's never a point in time where we don't know what we have, we don't know where it's stored, we don't know how to recall it, we don't know the history of all of those samples, and the Matcher database enables us to do that. So that's really supporting the preservation of the species, by tracking the biological data as well as tracking the biological samples themselves.
Okay.
Yeah.
We've lost a listener, haven't we?
Thank you, Matt, for that. And
You're welcome.
I think that it's so critical, obviously, from this side, having that database behind this. And obviously, when you're moving samples in or out, the whole thing's tracked, isn't it, from start to finish?
Absolutely, yes. Yeah. That digital footprint is equally as important as the physical samples that we're tracking.
And remind me, so it interacts with other databases as well, can't it?
Well, that's another feature of the matcher system that we're using, that there is an ability to be able to integrate with other systems. So that's the beauty of a database, is that you can have that interoperability.
Yeah.
So, for example, the systems that are being registered in other systems, those unique identifiers can be imported into the matcher system, so we can contain that digital chain of custody seamlessly. And it's really important that there are no gaps in that chain, all the way from the live animal themselves through to the removal of the tissues and the cells for long-term storage, into storage and beyond, as we said, when those samples are then removed either for research or for regeneration of the species. That might be next week, but it might be in 10 years' time.
Or 100 years.
Or 100 years' time, yeah. So we need that digital footprint to be continuous. There can't be any breaks in that digital chain of custody. We need to be able to know where those samples are. And as the biobank grows, which it is massively, exponentially, we need to manage those samples.
I think we've got nearly 7,000 samples. We'll talk about it next door, but I think we've got sort of 6,000 or 7,000 samples now. So
you couldn't track them on a piece of paper.
No.
You couldn't track them in a ring binder or a folder, even on an Excel spreadsheet.
And I always think, don't take this the wrong way, but I always think this is sort of maybe the non-glamorous side, the boring side. It's always the non-glamorous side, but it is absolutely critical.
It's just as important.
Not being boring now.
No, that made the cool stuff as well.
Yeah.
In many ways, this is cooler.
Well, thank you very much. We're now gonna, hold on to your hats, everybody, because this is the bit. Put down your food, get a glass of wine, because this could get a little bit gory now. So we're going to move into the main lab now. Have we got? I don't know whether you've got another poll question, but thank you, Matt, for that. That was brilliant.
Welcome.
Just before we leave, Matt, you've been a trustee of the charity now for 5-6 years now.
Yeah,
Right beginning.
at least 5 years.
Yeah, you must find it interesting the way it's seen its growth.
It has, yeah. I mean, it was a bold move. It was a confident step. It was an initiative that was taken, but it's really a team effort. It's about bringing people together. It's about bringing that expertise together. There's so much we can learn from the scientific community, both in the animal sector and the human sector. And we can share that knowledge. And I think for the benefit of the conservation of species, it's absolutely vital. Yeah. So it's been a real privilege to be part of it.
No, really. Yeah. No, I really appreciate that, Matt. And I think any of you out there, go on to NatureSafe website, naturesafe.com. Click on, I think it's about who, isn't it, Alice? What's the way we want to see people, or who we are? What's the section on the website, whatever it's called? It's about us, is it?
Our team.
Our team, that's it. Scroll down, and honestly, you will see a lineup like you've never seen before of professors and scientists and advisors. It's incredible. It will blow you away. The people behind the scenes. Yes, we're lucky. We're at the forefront of it, but there's those scientists behind that make it happen. Anyway, enough for me waffling.
Yeah, come on.
Yeah.
We've got another poll question for you. I hope that's filled in some gaps of your knowledge about Nature's Safe. But this question, would you like more information about Nature's Safe? You've got 3 options. No, you're already a big fan. Yes, you'd love to know more. Please send me details. He's off. We're off. And or 3, no, you'd really rather be watching Traitors.
Yeah, I can't wait. I am so hooked on Traitors. I can't tell you. Anyway, it's also all the writing on the wall when the Welsh lady came out. So yeah.
Yeah.
So I just want to. This is our main lab here. One of the other labs, and just want to take you through. So this is Pam. Pam is yes, you were warned. So Pam is our lab manager here, and she's this. I have to be careful how I phrase this because it could be taken the wrong way.
I
But there's nothing you don't know about sperm and how to process it from so many different species.
the best.
Yeah. So Pam's very much helps out Nature Safe. But obviously, a day job is obviously with Stallion AI, and we've got a horse testicle here. Is that
Yes, that's the horse test.
And what's this process called, Pam?
So this is an epididymal semen harvest. This is where we take a testicle from a deceased animal or a elective castration, and then we can remove the semen. So this is the whole testicle, and this is the epididymis. So this is the semen storage part of it. This is the sort of factory where it's all made.
So we don't need this bit.
No, we don't need this bit. This little bit on the side here, I'm going to hold the testicle up. Sorry, guys, if you're eating your dinner. That bit, okay?
All we need.
That is the tail of the testicle, or the epididymis, and that's the only bit we need. And then this long tube here, which is the vas deferens. All of this just goes into our clinical waste. So,
Yeah. And guess what we were doing on Christmas Eve?
Yes, it was Christmas Eve.
It was Christmas Eve. Yeah, we had an animal sadly passed away, and yeah, we were dissecting the testicles, and it was part of the cat family. And it was amazing because
It was really good.
it was really good. Those testicles were
24
hours old, and generally, I think with epididymal, we want those testes with us ASAP as soon as we can get them. And you always got to think the longer they're in transit, the decoration of the sperm. But it was a good one, wasn't it?
Amazing. I must admit, if we could have them same day, that would be perfect. But 24 hours old, and we got semen, and it was motile, and we went ahead and froze it. So we were really pleased with that one. That really went really
Now, I always think when you're processing tissue, it's a very sort of it's one sort of process, but semen is different, isn't it?
No, the semen is
So-
very different.
Do we freeze the rhino the same as a elephants, the same as a horse, the same as a mouse and chicken frogs, or is it all different?
That would make our lives really easy.
Yeah.
If we could do it like that, if all animals went in one media, one process, brilliant. But you'll get some testicles that are tiny, they're teeny tiny, and then you'll get some giant testicles. And then just to make it really difficult, every species will freeze in a different type of media. So the media that we add to the semen to keep it alive, let it freeze, every species has a different media that it likes. So some of them, this is our equine media here that we use. And then this is one that we would use for the big cats. And this is one that we would use for canine animals. And then this is a clear one that we might use for fish. So there's different medias. I know they all look the same, but they're not. There's different sugars, cryoprotectants, amounts, salts. There's so much that goes into these medias, and every single species likes a different type of media, and we have to figure out which one it's going to work best with.
And you've got, I remember when we started out with the spreadsheets were quite small, and now.
They're huge now.
And how do you determine, say someone says, right, this species we've never done it before, because sometimes they haven't. How do you sort of determine what to use? I know it's a bit of finger in there, but what's the process of that?
Google is very helpful.
Yeah.
So we'll go on and we'll have a look. And has anyone done this species before? No. Okay, so what's the next nearest species? Has anyone done that? Yes, we have. Okay, and how much success have we had? And then we'll have a look and see where they think there's been issues. Can we make up? And we can make up the medias.
Yeah, come over here. Have a quick
We'll
see.
look in the. Don't show them anything they should see.
Basically, there's so many chemicals in here. I can't show it all. It's top secret in here as well. But that just shows the lengths that we have to go to. And yeah, I know we sort of make light of it, but I always find, it's quite tense. Sometimes a species come in here that no one's ever done before, no one's ever frozen before, and it could be critically endangered. And the pressure you feel, and we have to admit, a lot of times it doesn't go right because you're still finding, but you still learn from that. So if it doesn't go right, you change a different method next time it goes in. And quite often these species may have died from an illness or old age, so the semen quality isn't going to be great. But when you get a win, it's a weird thing. You might not, sitting down in safe, you might not sort of really realise, but we get ecstatic by it. It is incredible.
It is when you've got one and nobody's done it before, and you just think, oh, this is a true finger in the air, and we freeze it, and it freezes well, and we just go, oh,
yeah,
and it's just the best feeling.
Do you have a particular species that you've got? Sorry, go on, Danny.
Species.
What do you go, Pam?
You got a favourite? So
I was just going to bring you back to the epididymal and
Oh, yes,
ask
sorry.
you how long this process takes, because
Now,
sometimes they come in the small hours of the night.
yes, that can
It's
be
quite
very
interesting.
species dependent. Again, it depends. If we know what we're doing, then it can be 2 to 3 hours. If we don't know what we're doing, it could be 5+ hours, depending on the testicles, where the epididymis is, how we're going to flush it, and then how we're going to freeze it. Because yes, we've got the different medias, but there's all the different ways of freezing it. So some animals need a very long chill time, some animals need really like a longer time in the freeze before we can do anything with them, or it takes ages to pack the semen because we've got lots of it. So it's not a one size fits all, unfortunately. It doesn't matter what we do.
Right, so we've had a question come in about the drugs. Does that affect the semen quality? It's an interesting one with drugs, because obviously the large part, we must probably do one of these a week on a horse, most probably, roughly. Sometimes you get 3 or 4, sometimes you don't get any. And at the moment, if they inject anaesthetic into the testes, they want to keep it away from the epididymis. Obviously, it depends what drugs that particular animal's been on. So obviously some can affect them, some don't necessarily. So it does slightly depend on the drug. But ideally, when you're doing this epididymal, you ideally like the animal fit and healthy, which isn't always the case, because obviously the animal's died or something. Or sometimes it's been castrated for other reasons. Say there's a male that wants to be introduced to a herd and they don't want the male tendency. Sometimes they get, so we have had testes from that side of it as well. So
yeah, I mean, as Tilly said, most of our testes are coming from older sick animals, which may not have the best semen quality, and it would be great to have them where they're fit and within their breeding parameters, but we'd rather have that attached to the animal actually doing its job without us having to harvest the semen.
Right, I think we've got another question, Alice.
We do. So when someone submits a reproductive sample, so someone sends testes, do we let them know if we've been successful in extracting
That
semen?
we do, yes. We have
That's a very good question.
sheet.
We have a sheet, and oh god, you're going to let us down now. We should have put something on there, but yes, and that is, we're always learning from this, and obviously there's a lot of zoo partners and zoo people watching on this, and we always love to hear from you. But we've now got the report. I filled out one the other day. Well, I had to get a new piece of new pen because we're running out of ink. So there's a lot of stuff we write down. We take pictures of the size of the testicles. We put measuring, so we weigh them, measure them, photograph them, and write down all the data, and then we send that back to you as a report. So you get a much sort of bigger report. To be fair, when the tissue comes in, obviously it just gets banked unless we go to the cell lines, but this very much so. And you know, we want to give you that feedback.
So Pam, can you take us through what are you looking for when you analyse sperm?
Oh, I'm looking for sperm to start with.
Yes, that would be
So
great.
that is the
Yeah.
first thing. So
Yeah.
when we do this epididymal, we would then flush the semen, hopefully, out through a little hole. So we put a needle in the top, we flush it through, and we put it on the microscope, and we're looking to see, one, have we got semen first? And secondly, is it moving? So we're looking for concentration, number of cells, motility, so what's moving in that sample. They're the 2 key things to start with.
And we might in a minute, we're going to thaw some semen out and just show you how it works. Minus 196, but anyway, not going to sort of jump, just spoiler alert, yeah. So
we've got a question.
Another question?
We have another question related to semen and extenders. So do you have some sort of database you use to then choose which extender you might use in a particular state?
We have our database. So we, as I said, we look at Google first to see if anyone's done anything out there. And if anyone's got any really good, please send us anything you want to do with semen. I'm quite happy to learn. However, we do have a big database and we will search that first to see what's been done. And as I said, we'll look at species and try and categorize them. So you might have your canines and your felids all in one, and then just move around and see what we've got.
Yeah, so we have, as I say, we've got our own database, but there's lots of papers out there. Some are very, very old. Some are fairly recent. And so we mix and match. And as we've been dealing with sperm for nearly 30 years now, cryopreserving it, we add our own take to it. And sometimes the results can be incredible.
Yeah, I mean, we changed a bit of equine with 2 steps and all sorts.
Yeah.
So
I remember we did the Southern White Rhino test, he came in, and it was incredible. Absolutely incredible. Yeah. I mean, the semen, we thawed it out and it was just amazing. But they're not all like that.
Have you got a species that's been particularly challenging to freeze?
Oh,
There'll be a
dear
few.
God.
Yeah.
You could pick the top two that have been really difficult.
What, the mountain chicken frog?
Mountain chicken frog was tricky. Your crayfish.
Oh, yes.
So you've got to try and find the sperms on them.
Yeah, we'll find those things. There might be some recent.
You can see right the way through. It's multi-species. Yes, sort of the bigger the mammals, the slightly easier it is. The cats we've fairly got tuned in now.
Yes, we're good with the cats. We're good with the dog. Good with the species. All we're getting there.
Because we have behind us there's another company that does freezer doxing, so we can use all that knowledge and technology and throw it into here.
Yeah, and we're always willing to learn.
Brilliant. So
What we talk
we're going to take now. I just said now Mike was going to ask them when he's talking as well. So
On to the poll questions.
answers to poll questions. Yeah, we've got 63% would like more details about Nature's Safe. Over 30% are already a big fan, and only 3% of you want to be watching traitors. So that's not too bad.
I'm 4%.
But
Yes. Brilliant. Anyway, so we are incredibly lucky, and I say, yeah, Debbie's very much at the helm of this charity, but there's a massive support behind it. And one of those people is Kit, who, from Tyndale Vets, who's been a wealth of knowledge, and it's really added a new dimension to the work we're doing. Whereas before everything comes in, now he's going to explain he can actually go out to the zoos now, and Pam's been with him on several occasions, and I've yet to done that. I can't remember whether I've been out there or not. I've done obviously lots of other stuff with elephants on the field, but Kit's going to give us a bit of looking into his world. As I say, you thought that was gory.
yeah, there might be some pictures here too.
So 18 years old plus, or 18 plus, I think this one.
Rated.
Yes, X rated. But Kit, can you hear us, Kit? Okay.
Yeah, all good.
So yeah, Kit, it's
Over to you.
It's over to you. I mean, obviously we've known you for a long time now, Kit, and it's just been great to see the work you're doing, and great to have somebody in this country that actually can go out and do these health checks on these animals and do electroejaculation. So yeah, it'd be great if you got a few slides and share them and tell us a little bit about the exciting work that you're doing that adds on to some of the work we're doing.
Of course, no, thank you very much indeed for those very kind words, entirely unjustified. So just as a bit of background for myself, my original sort of background, I worked out in Africa for a few years, but I'm currently in practice down in Gloucestershire. We're a 14 vet team, but we have a fantastic advanced breeding team that supports. So we do all sorts of fertility work with domestic ruminants and farm animal species. My particular area of interest and knowledge is deer, but actually that's led us to an awful lot of different things, and the eagle-eyed amongst you will notice that first picture in fact isn't a deer. So I'll just talk a little bit about some of the fertility assessments we do on the various different sort of species, what sorts of things we look for, and what criteria we use to try and actually make these assessments. As the guys have alluded to, I do apologise. Well, I don't really apologise. There's a few various gory pictures in here, but nothing that's particularly graphic. Well, nothing that's particularly bloody or graphic. It's just various different organs. So we will start with the boys, and we may as well start with a nice lion penis. So when we're looking at male fertility assessments, it depends entirely on the species on what different criteria we use. So each different species will have lots of different ways of sort of assessing, but fundamentally speaking, what we're looking for is testicles and any external genitalia we can get. Obviously, different species, different taxa will present those in different ways, and we'll have different criteria that we use, but fundamentally we're looking externally at what we can find. So testicles wise, we are looking at sort of size. So size very much correlates to the amount of testosterone that's produced and the potential semen quality that comes from there. We'll have a good old feel of them. So we're looking for sort of a nice firm testicles, no particular areas, either the masses that we can form or sort of squidginess that can determine that the testicles themselves aren't particularly healthy or aren't processing semen in the right way. We'll usually pop an ultrasound scanner on them to make sure we can't see anything that's wrong with the physical architecture of the testicle whilst it's still attached to the animal. And we'll also have a look at the penis itself, so we can see there's various different sort of congenital defects, so things that can be wrong from birth, or physical changes as the animals age and get older. So we'll look at the physical anatomy that's there to see if we can see any abnormalities. And depending on the size of animal, we'll potentially also have a look at the accessory sex glands that's on the inside as well. So we'll have a look on an ultrasound, and if the animal's big enough, then we'll have a palpate. So it's not just the testicles that produce the sperm, we've also got accessory sex glands that produce the fluid that the sperm actually lives in once it comes out. So obviously the outside is only part of it. What we actually want to do and what we're trying to do as part of that assessment is to see if those particular animals are producing semen, and that the semen that they're producing is good enough to establish a pregnancy, or whether that animal is fully fertile or what's called subfertile, where it might work some of the time but not quite as optimally as we would hope. So we've got different ways of collecting that semen itself. So on the right hand side there, you will see the manual collection of a reindeer. So it depends entirely on the species, how angry they are, how domesticated they are, on whether manual collection is possible. With things like horses, where you can train them to jump dummies, then it means that we don't have to do any sort of anesthesia or any further intervention to be able to collect that semen. It's just a sort of a training process. But certainly with the zoo animals, or where the animals aren't used to that sort of process, we'll have to knock them out, so anaesthetize them or heavily sedate them, and then collect the semen through a different mechanism. So one of the ways that we can do that is something called urethral catheterization. So the semen itself will come out of the vas deferens and then go into the urethra, and there will be some residue, or there can be some remnants of semen that's left in the urethra. So actually, by simply popping a tube up the urethra, we can collect samples that are sat there that are good enough for assessment, and occasionally they can be good enough concentration to do something further with. But sometimes we'll get samples there for assessment and to see what we've got kicking around. The other method that we've got for collecting semen from animals that are anaesthetized is what's called electroejaculation. So those accessory sex glands I was talking about earlier, the ones that produce the seminal fluid, what we can do is we can use an electrical pulse to stimulate those and actually induce an ejaculation that we're then able to collect. So we can collect the semen in relatively good volumes by that mechanism for further assessment. So we'll get a better volume than we would do through urethral catheterization. So once we've actually got the semen itself, we'll have a look at it. First of all, we need to think, is this a representative sample? So if we've got if we've got a male that's not actually been anywhere near any females for a good old length of time, there's every chance that the first sample that we collect is what's called a rusty load. So it is literally that the semen's all that's been sat there. He's not expressed himself recently, so the semen that we've got is all old and dead. So actually, that first sample can sometimes look pretty poor, but actually that animal himself is absolutely fine. It's just that the first sample isn't necessarily representative of what he's producing. But fundamentally speaking, we're actually, as Pam said before, we're actually looking for semen to be produced in the first place. It's certainly not it's not impossible for there to be absolutely no semen production whatsoever. So even though they'll ejaculate a fluid, there's actually no sperm that are sat in there to be able to generate that pregnancy. And then the actual sperm cells themselves, we're looking for defects. Is there anything that could be indicative of something going on? So we can see, depending on what the defect is, we might be able to identify problems with that maturation process where those sperm cells grow. And then once we've got that sample, we can then assess it to see what the possibilities are. If it's a very good sample, we might be able to process it, freeze it for use for things like artificial insemination. Or it might be that it's a poorer quality, but it's still worth freezing, because actually, if we can get away with using just a few sperm cells for more advanced techniques like in vitro fertilization, IVF, then that might be an option. So we look at what we can do with that sample once we've collected it. So as Pam said, how we actually go cryopreserving that semen will vary massively depending on the species itself. The quality of semen might determine how we're going to use it. So that's where I was saying better quality might be suitable for artificial insemination. But actually, we have to think about other things. So is that semen, if that particular animal's genetics might be useful in a different country for a different EEP, is there something that we want to be looking at in terms of exporting that semen, or doing things like that where we're able to move the germplasm instead of the animal? We can make a bit of a decision to whether we cryopreserve on site, or whether actually we can take that sample fresh back to either the Nature Safe lab or the lab that we've got to be able to process it further. So if we're worried that in the field it might be a little bit delicate, or we haven't got the facilities there, we can just move it around. So the semen itself, once it's out, is relatively stable. So we've got a bit of a time window to be able to move that to where it needs to be. But obviously, when we are cryopreserving the semen, we need to think about what else we're cryopreserving with it. So actually, is there anything that's particular in the history of that animal that we need to think about for disease testing, just to make sure that we're not freezing bugs and germs alongside the actual the sperm samples that we are collecting. So that's the male side, but we can also have a look at the female side because obviously the boys are only half of the story. In terms of the female reproductive assessments, actually what we're looking for a good chunk of the time, because most of the certainly most of the mammals, most of the organs that we're looking at are on the inside. Mainly what we're looking for here is ultrasound examination. So we can either do that through the abdominal wall, so we can try and identify the uterus through the abdominal wall, or we can use a transrectal introducer, so we can pop the ultrasound scanner in the rectum, and then we can be able to get a really nice visualization of the uterus and both ovaries from there. So what we're looking at in that instance is essentially what anatomy we've got and what state it's in. So in terms of the state it's in, certain species are seasonal breeders. So it might be that what we're looking at is an animal that's supposed to be cycling but isn't, or might be throwing sort of follicles and having a bit of ovarian activity where we're not expecting it. So we will need to sometimes time our female reproductive assessments, or both our male and female reproductive assessments, on the season. Sometimes, if animals have been contracepted in zoo collections, we're looking to see if we've got a resumption of cyclicity. So we want to see if we've got ovarian activity following contraception being withdrawn, so we can see that whether that animal's suitable to breed again. We'll also have a look at the breeding history. If that animal's bred before, that's a fantastic possibility for it breeding again. And age. So these things do change over time, and certainly the older an animal gets, especially if it hasn't bred, the more difficult it can be to establish pregnancy. So we consider all of these sorts of things for sort of how in our reproductive assessments. And whilst we're there, we have a look at essentially whether there's anything that we can do. So if we don't find anything in terms of pathology, if we're just finding sort of certain degrees of activity or sub-activity, it's whether we can do anything to influence that to start an animal that wasn't previously cycling again. So why do we do this? It's lovely that we get this information, but sort of so what? Well, actually, if we've got animals that have been put together specifically for breeding reasons, and we find that one of them is either subfertile or not, or we suspect is highly unlikely to be fertile, that might well change where that animal goes, where that animal's managed by the EP. So we might move animals around based on their reproductive assessments. Unfortunately, we tend to go and look at animals where there's already been a problem. So we're already sort of looking at subfertile animals. If you put two animals together and they breed, happy days. There's not necessarily a need for us to have a look at them. But if by the time that we're looking at them, there may well be an issue or a question mark over the fertility issues. And any issues that we do find, we need to have a look at if there's anything we can actually do, because some things that we can do something about, but there may be others that we may not be able to overcome. But the one thing with all of it is all of this has a big caveat of actually fundamentally what needs to happen is the semen needs to meet the egg in the right place at the right time. So whilst we can give a good chunk of the picture, it's actually still fundamentally up to the animals at this point to make the magic happen, as it were. So if we are collecting samples, when we're collecting samples, where we've got samples in the bank, it does open up a huge wealth of possibilities of what we can actually do with that once it's already banked. So certainly with some species, the moves can be quite challenging, and managing different animals, the actual move itself, if animals are particularly prone to stress, moving germplasm can actually be more beneficial than moving the animals themselves. So actually, if there's opportunities for artificial insemination, it may be that is a better mechanism of moving genetics, where imports and exports might be challenging for live animals, or the animals themselves are particularly fractious or not particularly good when they're mixing. So we have got other options depending on what species we're dealing with. From a personal point of view, I would absolutely love it if we can increase the number of opportunistic collections that we've got. Obviously, everything that we're talking about here in terms of the semen collection, the reproductive assessments, that all happens at the back end. If animals are being anaesthetized for health checkups or dental work or other things, actually it doesn't take that long for us to collect germplasm samples at that point. So even if that animal is completely healthy otherwise, if we're able to collect that sample and bank it, that means that we've actually got a sample from that animal to potentially be able to use or to be able to rely on in the future. Germplasm lasts, when it's in liquid nitrogen, almost forever. We haven't yet found the limit of what liquid nitrogen is able to last. Whilst the technologies for the actual preservation itself will move forwards, once it's in there, we can at least do something with it. But if we don't have it, we can't use it. And we don't know where the future might come. IVF is relatively is relatively well understood on the human side, and certainly that there's increasing knowledge of it on the animal side. But actually, is that potentially a technique we might be able to use in the future to be able to expand the gene pools of some of these species? So that's it from me. My email address is up there, but I'll be on the panel for the rest of the webinar. So if you've got any questions, please do feel free to email me or pop questions up in the chat.
Thanks, Kit. That was brilliant, absolutely brilliant. And as always, I find fascinating. And you and Pam had a bit of an expedition with a lion the other day, didn't you?
Yeah.
It was all over the internet as well. I was going to say 24 hours later, you were all over. I mean, that just shows, and that's worked well. And that was it an Asiatic lion? What sort of lion was that?
An Asiatic lion.
Yeah.
And it was just a simple. Has he got semen? Yes, he does. Can we freeze it? Yes, we did.
Yeah, that was incredible.
We got some lovely samples from him.
Yeah, and like you said, Kit, I think one thing that we've got quite a few zoos watching here, and I think it's important. I was going to ask that, but you emphasised that they're knocking him out for another procedure. You might as well do this, so they can be sore at both ends, sort of thing. But anyway, they have a dental.
See if there's semen, and if there is semen, we can then freeze
exactly. It. So yeah, I mean, it's because obviously, what you don't want to be doing is knocking these animals out too much. So if they're having dental stuff or anything like that, this procedure, it can be done quite easily, can't it, Kit? I think at the same time.
It's like a happy ending, but I don't think they remember it.
Yeah. Kit, can you hear us?
Yeah.
Yeah, brilliant.
No, yeah. I agree with Pam's happy ending.
I knew there was going to be some.
Going to go.
Right, so just moving on. So Pam, you're going to thaw some semen out now. So come this way. So this is semen down at minus 196 degrees. So this is.
See the straws there.
So that is pretty cold. So we're going to. And this is how quickly we can do it. So we're going to thaw some semen out now, straight into your water bath. How long would it take to thaw out?
30 seconds at 37 degrees. That's all it is.
So we'll literally put it in there. While that's thawing out, or Pam's doing, I'll just show you one here. There's other devices that we can use. This is called the iSperm. We took this when we do these samples. I think you took it the other day with the lions, did you? Yeah, and that shows the sperm tracks. You can show the full screen. And this is a great way of seeing what the semen looks like, how it's progressing. It tells you the quality, the motility, it records it as well. So instead of taking microscopes everywhere, we can take this device. It literally, it's an iSperm, picks it up, and it's fully portable like that, which is great. So Pam now has got the straw.
This
and you'll thaw it out.
Board. So we just snip the end off. Then we'll pour it into a test tube. So there's my sample. And then we're just going to put it underneath the microscope. So we only need 10 microliters. It's a very small amount. So we just pipette it up, put it onto a warm heating stage. Now the iSperm has its own heating stage as well. It has a portable one that attaches. So you don't need to worry about semen getting cold. Then, please be alive.
OMG, look at that. Look at that.
Teeny tiny bit of dirt just come across.
And that's incredible. I say we've done this for years and years and years. And that 2 minutes ago was at minus 196 degrees centigrade. And look at it now. Look at it go. Those sperm are just flying around. So that just shows what is possible. Obviously, you get various degrees of quality. And as Kit says, they're only, semen is only one half the story, but it is obviously, an important part. And if we don't get this bit right, obviously pregnancies aren't going to follow. So it's absolutely critical that we try and get this bit right. That's amazing. And not only that with the zoos, you were talking about reports. We actually take some pictures. We, Nottingham Trent University.
Yeah, Graham with his team.
Graham, brilliant. So we send these samples off and come and have a look at this. So here we have a sperm cell. So this is a lion sperm, is that right? And electron microscope. This one is a mountain chicken frog. How cool is that? So we don't know whether this is normal, abnormal, until we start looking at these pictures. We don't really know. And we've got a bit of a question. You can put it in the chat below. So we haven't got a poll question for this. Anybody guess what sperm which species does this belong to? That has got one of the longest tails out there. So put it in the chat. Anybody guess that? Let us know, Alice, if anything comes through.
Giraffe.
Giraffe. Oh, I think we've got a giraffe here.
Giraffe.
Here's a giraffe.
On the screen.
That's a giraffe sample. So it's close. Well, close on the screen. We'll come on to that one in a minute. Any more?
We have people guessing. Oh, rooster.
No.
Dog, snail.
No.
Octopus.
The closest.
Octopuses.
There's about 5 million species on the planet, so keep going. Anyway, it is a tricky one. But this is a close cousin. I don't know what you call it, a cousin to it. But anyway, look at this. This is one we just done. No one has really even hardly seen this picture. It's just arrived in.
Head starts here
There.
and it comes
It's
all
the
the way down.
longest tail
And
in the world. Absolutely incredible. And this is actually a sea urchin. But the winner of this one back up here, this is the one, believe it or not, that is coral sperm. How about that? How cool is that? I bet a lot of you out there didn't even realize coral produce sperm. They are an animal. They're one of the fastest declining species on the planet. We've lost 50% of our coral in the last 50 years. They're the lifeblood of our seas. And yeah, and me and Debbie, didn't we, had the huge privilege. Actually, Alice this year as well.
Last year.
So we had an amazing experience. Honestly, I do feel like I say luckiest job. I suppose I'm not employed, so to speak, but we have the luckiest jobs in the world doing this. We visit the most amazing places, and yes, it doesn't always work out, but when it does, and we did the coral first time last year, and we got our first ever cryo coral babies in Europe. And I know you and me, Alice, went down there this year, and we did a little bit more work. And how did you find it? What do you think?
It was really fantastic. So we were using methods that have been developed collaboratively. So it's ourselves and this cryo corals group, which also includes researchers from the Smithsonian, from the Natural History Museum, from Zoological Society of London. So yeah, it was a really great collaborative effort. So we went down to the Horniman Museum and Gardens, and we preserved semen from 2 different coral species and a sea urchin species as well. So I thought it was fantastic.
Is incredible. There's pressure, there's no doubt about it, and a lot of prep. The prep beforehand, you were making these 3D devices or putting them together and things like that. So what I can say to everybody watching here, if anybody wants to get involved in Nature Safe, I know we're going to put a poll question up later for that, but anything on this, we'd love to hear from you. It's all about, don't be afraid to reach out. We need help now, but we'll come on to that maybe later, but please let us know. Anyway, there's a video going to play a bit about our coral stuff now.
Last year,
So
Extinction Museum put this together, so I think we're going to play that.
So if you can play that, let's see how it goes.
At the Horniman Museum and Gardens, we've been focusing on coral reproduction for a long time now. This year, we're trying something new, and we've teamed up with Nature Safe to start a cryopreservation program. This is the first time it's been done in Europe. First, we have to collect the egg sperm packages ready to isolate sperm for cryopreservation.
At the moment, and we're using the ice sperm, and we just come across, now look at this. This is just absolutely incredible. This is coral sperm. You're looking at this under the ice sperm. Look at those sperm go. I wish some of the other species would have stuff as good as this. And we can actually really look to see how good a quality it is. This is just incredible, absolutely incredible. Let's hopefully we can get on and freeze it.
Having high sperm motility is really important for success in this process. The next stage is to add a cryoprotectant which protects the sperm during the freezing process. Here Tullis is now adding the sperm samples to liquid nitrogen, and we record the temperature as it's dropping. The process is finished once the temperature drops down to -80, and the sperm samples can then be transferred to a secure biobank. However, the next phase is to reanimate one sample just to check the quality of the sperm. So we defrost that and it gets mixed with fresh eggs. Once defrosted, the sperm is added to these fresh eggs for the in vitro fertilization process to start. 2 hours after
Don't worry, Lydia, if it's finished, we'll just go straight on to us now. That's fine. Yeah, can you see us okay there? Great, yeah, sorry, the video froze there, but it's not a problem. Come over here. One thing I missed actually before was Pam set this up. When we print the straws, just twirling inside. They can actually print it. You can see the straws coming out there. Press stop. And this has the animals' details on here, all uniquely written, really tiny writing. What they are, it's got Nature's Safe. I don't know if you can read that.
Yeah, and just twist a bit.
And putting Extinction on ice and the date. So yeah, so we can cramp. And these are 0.5 mil. And normally we're putting maybe anything from 50 up to maybe 150 million sperm in each straw. So sometimes, and then we're going to fill and seal them. So this is the device for filling and sealing them. And this literally, if you come in nice and close here, you can actually see the straws being filled. It's a bit noisy, but you can see the semen going into the straws, and then the other end seals it. Seals it. Anyway, so that just gives you, it's slightly jumped about the order there. I should have shown that before, but that just shows you a little bit about how the whole process works. The testicles come in, we extract the semen, we add our sort of amazing extenders, fill it into straws and freeze it down. Now let's go and have a look. I think every room's exciting, but this, the tank room, has to be one of the most exciting rooms. And it's like walking into a nuclear bunker. So, Debbie, lead the way.
Oh, that's okay.
So we're in the
Here we are.
in the tank room.
Sorry.
And this is, it's like Debbie says, it's like a nuclear bunker here. And we have concrete roofs, steel doors. This is where all the genetics are stored. And it is one of the most important rooms on the place, because if we don't store it right, there's no point doing any of this. So, yeah, if you come on in.
I'm just going to kick us off with a poll question, because you like this poll question.
This is my favourite poll question.
Your favourite. So, will you jump out of a plane to support wildlife? And you've got 3 options. The first one is absolutely no way. I did it though. Come on, guys, you can do it. Yes, you're there with your parachute on. Oh no, you'd love to, but you don't want to do that, but you would love to help in any other way. So poll question should be on the screen now. And
yeah, and so the skydiving, as I say, we've mentioned it before. Please let us. Oh yeah, there we go.
There we go.
So if you recommend a friend, you could obviously still say you'll do it, and you can just pass it on to a friend. It's basically £450 you have to raise, and you get the jump in with that. And it was the most fun time. Try and say yes.
Yes.
No, it's great fun. It
was amazing.
It was amazing, and Jimmy Doherty jumped out, and Stevie. One of them enjoyed it slightly more than the other. I'll let you guess who that was, which way round that was. But no, it was, and it's for us. Yes, as it's a free service to the zoos. This, isn't it?
So yeah, so the way it works, so we have partnered with conservation organisations around the UK. So that's zoos, wildlife centres, aquariums, all incredibly valuable organisations doing great conservation work. And we've got 100 on board now. And Sarah's got the giggles.
What is it, Sarah? Come on.
Barbara needs to know how many jumps you've done.
I've done just shy of 1,900 jumps and 11 base jumps. But no, at 1,900. But sorry. Anyway,
so yeah, 100 conservation partners on board, and we provide the service free of charge. So every penny and pound that we fundraise goes towards saving these samples, and providing indefinite storage, and a free service to all of our partners.
So I'm sorry, you're watching with your glass of wine in your hand. I think it's no small effort to jump out of a plane and just raise a little bit of money, don't you think? We'll have a lot of fun. Anyway, so right, we'll be interested to build up the poll question on that.
So just to give you a bit of an idea of what is in this room, NatureSafe has now got samples from 378 different species, which is an amazing number. It's gone up massively since November, I think. So yeah, we're doing fantastically well. Somebody asked earlier on what the smallest one we have done was, and that's the partulous snail, which is actually an extinct in the wild species.
How many of those have we got here?
We've got 7 extinct in the wild species in the tank.
So you're telling me in these tanks there is 7 species that you cannot get in the wild anywhere?
Correct. That is exactly what I'm telling you. So yeah, so
if it, I know it's might feel, but it actually gives you goosebumps.
Yeah, no, absolutely.
And I know sometimes we think we over exaggerate. I've come into this room, I do this talk, I don't know, 5 times a week, and every time it gives me goosebumps working in here, because you're thinking these species, this could be absolutely critical for their survival.
Well, it is. And, our conservation partners are doing so much fantastic conservation work. So, for example, for the species that are extinct in the wild, there's a lot of breeding programs that are going on to support reintroductions of those species back into the wild. And if storing samples can assist that, then we feel that's a really valuable input.
And how many sort of vials and straws?
Yeah, well, the numbers are going up. So we have 7,500 vials. So that's all the tissue samples, and we've got 1,500 straws of semen as well. So it's a pretty robust store.
Well, let's have a look around, see how it's stored, because it's good. I think we're going to this big tank here first. So this isn't actually endangered species. This is more on the equine side, but don't fall in, Sarah. That's my phone, so don't drop that in there, because I'm sure we won't be able to bring that back in 1,000 years' time. But this, you can see in here, there's nearly 250,000. That's right, 250,000 straws in this tank at liquid nitrogen. That just shows the scale this could be. But these are the tanks. You look here. These are the tanks. In this tank here, there's sort of 300 odd different species still alive. It's incredible. Each species still alive, and we have different species in here. Why do we got one with the amphibians on here? Why do we keep these separate?
Yep. So it's really important that amphibs stay in a separate tank, because amphibians are notoriously really challenging to cryopreserve. They have a lot of bacteria on their skin, and we just want to keep them separate in a separate container, so there's no risk of contamination through the tanks.
And here, special tank as well.
This is amazing. So
I've always quite dear to your heart. You've done a lot on the UK side.
We've done a lot of pushing through the last 12 months of preserving our UK native wildlife. Of course, we are one of the G20's most nature depleted country, which is terrifying. So we're losing hedgehogs, we're losing red squirrels, you name it, we're losing them really rapidly. So it's a really big push for us to help preserve our UK natives. So this tank's very special. So we've got Scottish wildcats, lots of UK birds, and some red squirrels and some hedgehogs in there.
Oh, cool. Yes, I've got a red squirrel. Yeah, the hedgehogs. I love a hedgehog. So anybody out there can help us. We want to try and preserve the hedgehog. We're always looking. So hedgehogs. Well, sometimes. Yes, not yet. And yeah, I just want to explain a little bit about between these living. What's that? Was that the 2 minute sign? Or should be rude?
Yeah. 1 minute.
Which way was the 2? So basically, if you were to put this glass, or you always say a bottle of wine in your freezer and forgot about it, it would rupture and break. And every cell does the same thing if we were to do it. Where we're different is we actually take the lid off, you say, empty all the water out the cell. You saw Lucy doing it out there, and some of the stuff that Pam's doing, add a special dilution that dehydrates that cell so there's no liquid in there. Then we freeze it, and then those cells save alive for 10, 20 or 1,000 years. Well, yes, like an antifreeze. Thank you.
Like an antifreeze.
Yeah. But that's a very basic, quick way of showing you. That's where we're different, because it is confusing why we're different from living plants. So I just want to maybe come a little bit closer. And here, I just want a bit of a shout out to MVE. They've donated this tank. They donated a couple of tanks, so thank you so much for donating this. But in here, it's a dry tank, so there's no liquid in here. So we thought I'd show you. You might, oh yes, that's coming out quite well. So that shows you what's in here, and at the racks. Here's what I prepared earlier. So this is how they sit in there. And you've got these trays, and we're going to lift that. Debbie McGee.
Yes.
Helping me there.
You're not doing magic.
Magic, yeah. So you can see how they're loaded into here. And these can hold, is it 81, I think 80 or 81 vials in each one. You've got 10 racks. My maths, you need to add it up. But basically, it's about 6,000 vials in one of these that they can put together. So, and they literally drop in, and this peg goes down. It would be with liquid nitrogen in it as well. So there you can just see how that can work, and then that gets lowered in. And the other thing that we're doing now is to safeguard the tip. We have to look at the risk averse. So we split the samples across the tanks, because the worst case scenario, if something happens to this tank, so we want to split the sample. So we're normally getting about 10 vials from each one. So we put that across normally about 3 or 4 tanks. That's correct. Yeah.
And I'm just going to answer. There was a question came through around ownership of samples. Just to say that the samples are all owned by the organisation that submits them to us, so they retain ownership.
Yeah. So we try and make it as easy as possible. Basically, at the end of the day, for these samples. Did you have a question then, Alex?
Yes, somebody asked if we are only preserving samples from species which are endangered,
Yes.
or if other samples can be of conservation value.
Absolutely.
So basically, I'll let you just repeat the question in case you couldn't hear it. Basically, do we in sort of just endangered ones, or do we do everything? So over to you.
So we don't prioritise on species, because we believe that everything has a potential value. So the point of what we're doing is trying to preserve genetic diversity, because that's what keeps species alive and well, and populations thriving. So the least concern, so we have the IUCN Red List. If any of you haven't heard about that, it's worth a look, where they categorise the planet's wildlife into categories about from least concerned to extinct in the wild. Now, we take species from across all of those categories, because the least concerned species currently have the best genetic diversity. And so those genetics are incredibly valuable. And least concern now might not be least concern in 10, 20 or 30 years' time. So we're taking those as well, all the way through, obviously, to extinct in the wild as well.
Brilliant, thank you. And I think that leads on really well to our next guest.
Next guest.
It's the one Stevie Shepherd.
Yeah, fantastic.
And Stevie, could you hear us?
I can hear you.
Brilliant. I'm not too sure whether we worked out who was the more nervous skydiving. We should have asked that as a poll question. That's it. I'd like you to endorse it, but I might get the wrong answer.
So
I wouldn't endorse that.
You are?
We've got him online.
Not again.
It's not good.
No, not good at all. I was ready to jump out
Right,
at 1,000 feet.
Stevie is
Hang on, yeah, what's the poll question?
40% said yes.
40% of you want to jump out of a plane. I'm so impressed.
But 41% would like to have it the other way. I think you're one of the 19%. Absolutely no way, was it, Stevie?
Yeah,
but no, I mean, Stevie is not only is the trustee of the charity, and yeah, I'll leave it over to introduce.
Oh yeah, no, that's fine. So yeah, Stevie's been a really valued member of the board of trustees for Nature's Safe, and he has obviously been incredibly influential and key part of Jimmy's Farm. So Stevie's going to talk to us a little bit about their conservation planning and how biobanking potentially fits into that. And I'll hand you over to Stevie.
Brilliant. Well, thank you very much. I just thought it was really good actually to come on here tonight and just show and talk a little bit about all the benefits that we've had from partnering with Nature Safe. Now, to start off with, it was a bit unusual. You know, we've got all this new technology. What's going to be the uses? Why are we sending our animals? Why should we be biobanking? And after the explanation of it, and also the most important bit is who is going to be owning the samples and who makes the choices of how they're used. And that was really important to us because there's lots of controversial, lots of ethical reviews that need to happen. And we wanted to make sure that we had the ownership, and the MOUs in place really protected us on that. And also from there, we developed into ambassadors for Nature Safe. And then obviously I've been a trustee now for just over a year. But I just wanted to tell you a little bit about the kind of things that we've been doing at the farm and the benefits that we've had from being a partner of Nature Safe and the kind of things that we're doing here on site. The first probably our most exciting project that we've launched this year, and that's a partnership with Nature Safe and Anglian Ruskin University, and that's the cryopreservation of butterfly eggs. So the British swallowtail butterfly is going critically endangered. We're losing their habitat, and very quickly we could potentially lose this species. So using the European swallowtail, that's really similar. We are currently on a road of discovery to learn how to freeze the eggs. So these are fertilized eggs that we could freeze. And we have done that through the partnership. And because it's so unique and so different, we've managed to receive full funding on the PhD through the university and potentially have funding for 2 more PhDs after this. So the research side for our collaboration here at the farm has been amazing. So we're going to freeze those butterfly eggs, hopefully collect a large amount of them, defrost them, grow the caterpillars here at the farm, and then release them back to the site. Now, it's all great when you talk about releases. We're going to release these animals. Are they going to do really well? Some people are releasing a few hundred a year with no impact. So by able to release 1,000 caterpillars or butterflies or more could be amazing. But we need time to restore the habitat. So working with Norfolk on the moors, we're actually establishing new areas. We're growing the milk parsley here at the farm, rebuilding that habitat to be able to sustain it. And Nature Safe, working with us on this PhD, means that we can preserve these eggs. Hopefully it works. We're still discovering that. But it gives us time to restore the habitat, because for many of the animals and the species that we want to bring back from extinction or to bring them back from failure numbers is due to habitat issues, human wildlife conflict. We need to resolve those issues, and we're losing animals on the lack of time and that it takes to resolve those. So it's really important to be able to have these sort of backup plans. And that's the second part really I want to talk to all of you tonight. It's about storytelling. We have really been able to tell some amazing stories here at the farm through our collaboration with Nature Safe. So the very first one that's been really good for us is we have some animal characters that have been here at the farm for 10 years, 15 years, 20, 25 years and plus. Those animals are characters, people fall in love with them. And sadly, at some point, they do die. And they've been amazing ambassadors for conservation and for the stories. And when they die, we seem to just stop and end it there. By preserving them with Nature Safe, we've been able to tell the stories of those animals, favorites that have been dead for 5 years, 10 years, bring those stories back, make people really reconnect with them. They remember those individuals they fell in love with. And we've actually started to see an increase in our donations into our conservation projects by reminding people of those animals that passed. And even though they've passed, by being stored with Nature Safe, we are still contributing to conservation. They are still there. We can actually release those samples for research, and we are looking at releasing some of our individual samples, because when an animal dies, and Talis will explain this more in a moment, I'm sure, but when they die, you don't just get one single sample. You might get 10 or 20 samples or more, and we can actually give up some of those for research, for conservation projects, and allow them to be used, which means those animal stories can come back and people can re-engage with those characters that they fell in love with. And that's really important. We've also had an opportunity to do a number of firsts since partnering. So this year we decided to castrate our male bear, Diego. He is a big character. We found him a girlfriend and he was a bit too frisky with her. So we decided to make the decision to castrate him. We spoke to the EP. They would like to see if there was a way to preserve him. So we sent his testicles up to Nature Safe to preserve his sperm. And Jim raced all the way up to Nature Safe. He actually got a speeding ticket on the way up there. And it was really hard to explain to the police officer that the speeding ticket was because he was carrying a set of testicles up to get preserved. But it was well worth it. We managed to preserve a number of samples and we froze them, defrosted them, and only saw a small percentage decrease in the viability of that sperm usage. So he is now preserved for potentially 1,000 or more years. So Diego can actually breed, he can have offspring in the future, he can contribute to conservation efforts. But for us here, from a management point of view, we had to make the decision to castrate him. It wasn't a decision that we took lightly, because obviously the conservation value could go. And with him, we were able to make that decision and not lose the potential conservation value in the future. So that's been really good for us. And actually, we believe it's a world first for his type of semen, the way it was frozen and defrosted. It's been done in Asiatic black bears before in Japan, but not with European brown bears, not in this way. So it is a world first, and it allows us to get that news and get that interest out there for the public and help us to continue to raise that sort of awareness. And as I said earlier, we have actually seen an increase in donations for our conservation efforts. People get really fascinated by the Jurassic Park sort of theme. We don't like to use the word too much at Nature Safe, but we are potentially storing these animals to either bring them back or to find uses. But we're not looking to find those uses right now. We're preserving for the future. And that's really important. We don't know what we're going to be doing in 10, 20, 30 or 40 years time. We don't know those animals that are least concerned, that might be more endangered in the future. So we're actually doing conservation for the future and looking at the IUCN and how they're making more hubs around and more evaluation into those species. Some of those animals are not evaluated for 10 years. They can drop drastically within those 10 years, and we can see a least concerned animal go all the way up to endangered or worse. So it's really important that we start thinking about all of the animals within our collection. The kind of things that we're sort of telling to our members of the public is that Nature Safe is a backup plan to all the conservation projects. It's not the core plan at the moment, but it is the perfect backup plan. We've got reintroduction, we're doing breeding programs part of the EEP, but if they don't work out, this is a backup plan so that we can do those suitable populations. With a number of the EEPs now, they're asking for potential breed to cull, so we can have these animals cycling. We haven't got individuals that are sitting there. Those animals that are being bred to cull, this is a potential for those to be preserved and to be used in the future. So they're not potentially a wasted individual. They can still contribute, even though they may have only been bred that one single time. For us, another one that we've had is we have a number of rescued individuals, Barbary macaques that have come from backgrounds such as laboratories, ex-pet trade. They have a lot of behavior issues. They don't interact. We've actually not had successful breeding within one part of the group. All of the individuals are mixed ages, and we've actually started to preserve those individuals with Nature Safe because their genetics are so great. They are an endangered species. They are in decline, and we are starting to bring those individuals together and preserve them because we're not having successful breeding programs here with them. Another one as well, we've had a number of issues. I know in many zoos, contraception, we're having to give our animals contraception. There's been huge disease outbreaks from avian influenza to blue tongue that stopped the movement. Brexit has obviously been another one as well. And we've not been able to move these animals around and to get that sort of breeding. Again, we are preserving semen, eggs, if we're losing individuals, if we're neutering them. And also for those individuals that we are preserving that wasn't able to breed due to being placed on contraception early. There is a future element of, if they're really high value individuals, could we clone? Do we clone? Do we bring back insemination into those animals that, that aren't having a population? Do we send semen out rather than individuals across programs because of housing requirements or issues? And we are seeing that more and more throughout the sort of EEPs and the programs that we are part of. So it's been a real sort of good journey for us over the last few years. We've got our big research project. We're doing lots of storytelling and increasing our donations to the conservation projects, just not only this, but a number of those breeding programs and our in situ and ex situ conservation plans. But then lastly is that conservation of the future. What is that? What does that look like? And because we don't know, it allows us to really invest into Nature Safe. And that's why donations are so important. A number of collections use it, 100 partners, we send in samples, but we don't currently receive any donations from any of those partners, I believe. Tell us yet, and Debbie, they might be able to tell us a little bit more, but the donations are so important. If we can fundraise, if we could raise money for Nature Safe, we can preserve those in the future. We can release some of the samples that each of us are in control of for research and conservation and do so much more. The world is our oyster and the science just keeps growing and growing. But I'm going to hand you back. I just want to say a big thank you. If anyone has any questions of how we've done it, feel free to pop me an email. I'll pop my email in the webinar chat, and you can ask away on those questions. But thank you very much for having me.
Thank you, Stevie. Honestly, that was incredible to listen to. When we build these nights, I have to admit, you don't know how they're going to unfold. And listening to people like yourselves and Kit, it's been incredible. But the night is not quite over yet. We have an esteemed panelist here, all the people behind the scenes, as well as so there's some questions come in, and I think is Alice, you the quiz master?
Yes, I am.
Yes.
Yeah, we've had so many great questions come in, both during the chat now, and also some people submitted questions when you signed up for the webinar. So, are we ready to go?
I'll get a bit nervous when it is bit. You think, God, please not me. If it's any technical, really difficult ones, there's Lucy sitting in the room. Yeah.
Well, we'll start off with a bit of a doozy, actually. So, I mean, I think
A bit of a doozy.
Stevie did a great job of starting to explain this, like exactly how this work fits in with other conservation work. But generally, there was a question, which is essentially like, what are we actually going to do with all of this saved genetic material if the environment itself is degrading? So how does this kind of fit in with the rest of the conservation world?
Come on for you, Debbie.
Yeah, I'll take this. So we always maintain, conservation is a global effort by a number of different parties, and Nature Safe is just one tool in a vast toolkit for conservation. So we're saving genetics so that because we can right now, so why wouldn't we? There's no harm in doing that. And everyone else, there's so many other organizations and people doing amazing work around the world to try and restore habitats and try to preserve the environment for these wildlife to be able to live on our planet a little bit longer. But I'm going to pass on to Alice and Lucy to talk about some scientific applications that can really help.
Yeah, so in a very practical sense, we can sort of talk you through what the samples can really be used for. So I think the most obvious and immediate example is our semen preservation side. So if there is an animal population that is held in captivity or semi-managed in the wild, and they're starting to lose genetic diversity, if we have semen samples banked from genetically important animals, then we can use them to artificially inseminate females and try and boost that population. There's also some more advanced techniques like culturing ovarian and testicular tissue. Maybe Lucy can tell a little bit more.
Yes, and I know also an additional message is the fact that biodiversity feeds into climate systems on the planet. So preserving biodiversity is also important for the wider picture of climate control and actually having a really healthy planet. So that's where it feeds into the wider question that the person asked there. But yeah, other uses of the samples that we're preserving sections of ovaries and testes with the hope of producing laboratory-grown sperm and egg in the future, and that then feeds into the reproductive programs that Alice has mentioned there. In terms of the skin samples, there's technologies available for using them now, whether that be genetic replication of animals, through cloning essentially, but that's just one tool in the toolbox. Other applications are maybe we can turn skin samples and skin cells in the future into sperm and egg, just as one example of the technologies that could then feed into creating fresh genetics for the future. I think because our planet has so many challenges against us, this is why we're needing to think out of the box and come up with novel solutions and ideas such as these to help in not only reducing biodiversity loss, but restoring it for the future.
Yeah. So yeah, the key is we're working with conservation organizations who are already doing these managed breeding programs. So essentially, by preserving this genetic material, we're helping to prevent species extinction, and that's the core of it. But we need everyone really to collaborate when it comes to conservation. So in-field conservationists and us here in the lab as well.
Cool.
Okay.
Right, another question.
Okay.
Sure, there's a whole list of them. I think I've seen them coming through on your phone. There's been loads coming through. So yeah.
There have been. I think, why don't we start with one for Pam? This was one that came through. I know that you answered it in the Q&A, but it might just be interesting to answer on camera as well. Have you seen any sort of correlation in actual sperm size related to the size of an animal before?
I've not seen it. So we've never looked at an elephant sperm and gone, oh, it's enormous, and then a mouse sperm and it's very small. However, interesting fact, fruit flies have the longest sperm cell in relation to the animal. They're absolutely enormous. So that was something that we didn't know about, and Google's amazing. But yeah, I've not seen a big sperm cell with a big animal.
But you've seen one with a big tail.
I've seen one with a very long tail.
That's sea urchin.
But that sea urchin is this big.
Yeah,
so
it's the longest. It's incredible.
It's enormous. I mean, they couldn't get it all on the whole picture.
The largest sperm comes from a plant, which is fern sperm.
Fern sperm.
Yeah.
Say that 10 times fast.
Yes.
Okay, I didn't know that either. I'll Google that one.
All right.
Well, we were also asked a question related to de-extinction. So maybe this is a good opportunity to just kind of ask, is de-extinction the name of the game with Nature's Safe? Tell us, what are we really wanting to do ultimately?
It's a hot topic. There's no doubt about it. We get this asked an awful lot. And we're not here about de-extinction. We're about saving what we have here and now. Obviously, the science that's been used with other companies doing that is interesting, but that is not what Nature's Safe is about. We're trying to preserve the species that we have here now on our planet and put that sort of technology that we have to try and preserve them at the end of the day.
Fantastic. And a question here that would be good for Grania that we got through earlier. Is it only zoos that we partner with, or other organizations too?
Yeah, that's a really good question, because we have been talking quite a bit about zoos, and animal collections in general are all welcome. So as we mentioned down in the tank room before, we work with 100 now conservation partners, and there can be anything from zoos, aquariums, wildlife parks, sanctuaries, basically any animal collection with street and college collections as well. Yeah, very true. So any collection that's got animals in it that would be worth preserving, we're happy to work with them. And if you're interested in joining on, you can get in touch with us. You can get in touch by emailing office@natures-safe.com. That always tricks me. Or Grania@natures-safe.com. And you can email us and we will take care of everything else. We'll get some paperwork done, get the onboarding process sorted. And yeah, it's that simple, really.
And I was amazed that, a year and a half ago, we roughly had about 25 zoos or something on board.
Yeah.
And we've got 100 now.
Yeah.
And as Grodin said, that we know there's people watching tonight that may have joined yet, or maybe thinking about it, not too sure. Just go on the website. If you didn't get the email down, you can find all the information. We'd love to hear about it. If there's any tricky questions about ownership, hopefully we can allay them. So,
and just to say, we send you everything. If you're a partner of ours, we send you all the sample boxes. Everything's free of charge. You just have to pay for the postage.
That's the only thing you do.
It's the only thing you have to pay for. We take care of everything else.
And we're pretty much, we're doing this on your behalf. We're storing these samples on your behalf. So like Debbie says, the only cost to you is that postage back to us. Cool.
Brilliant. And speaking of sample ownership and custody, we have a question for Nat. So how far have we really come in terms of database management for biobanks? Like, what was the first iteration of data storage?
It's a long way. Yeah, I mean, in the early days, biobanks were relying on paper-based systems, manual data input into simple spreadsheets, which is great because the data's been captured, but it's also prone to transcription error. That data's not really been captured in real time. It's difficult to use the data to help drive efficiencies, to communicate. So as we move more into the digital age, we can harness the skills of some fantastic teams of software developers who can really focus more on taking that to the next level. So real-time data capture using barcodes is one example of that, where those barcodes that have been scanned are not only allowing you to capture the information in real time, but they're empowering data exchange through where it's improving the way in which we can communicate throughout that landscape. So the zoos can communicate better with the biobanks. The samples are safer, so there's a lot more focus on the risk elements to the safe storage and management of samples. And as we said previously, that traceability is just as important as the storage of the physical samples. We need to know where the samples are. We need to be able to analyze the data so we can use that to facilitate a more efficient use of biodiversity, and it continues to evolve even further. So it's come on a long way. Yeah, it's fantastic. I think what's good about Nature Safe is they had the foresight to put those systems in at the beginning, so there's no retrospective data analysis or data capture being required. We're evolving as the systems evolve. Yeah.
Brilliant.
Fantastic. We've just had a new question in as well about customs requirements. So what are the requirements around sending and receiving samples? So we'll say within the UK, because our partners are within the UK.
And it's because obviously we've got Kit on here as well. And you might be able to talk about on the other side, but we can maybe do some of the ones. But yeah.
On a basic level, but I will get Kit in, but on a basic level for samples within the UK mainland to us is very straightforward. Not on the mainland has its challenges, particularly with CITES animals trying to get biological samples, particularly those that are in a living state, which ours are, is particularly challenging. But Kit might be able to talk a little bit more around the transport of
blue tongue, blue tongue on that side. Kit,
I was going to say, if we're looking at trying to bring samples into the UK, basically we'd need to look at it on an individual basis. So if that's something you want to, investigate, speak to us directly, and we'll see how we might be able to facilitate that.
And with the blue tongue, Kit.
So blue tongue is a challenging one. So there are certain licensing requirements to be able to process semen from certain species that are blue tongue susceptible. Again, if we're looking at those, it's best that you speak to us on an individual basis about the blue tongue side.
Brilliant. Thank you very much, Kit. It's always a little bit. Thank you.
Okay, brilliant. Moving back to a technical question about cryopreservation itself, which myself and Lucy can answer. We were asked if you can take samples from bird eggs. So I'm going to expand this as well into reptile eggs too, and eggs from different types of species. So just to start off, bird eggs it's not really the right type of sample for us to take. We really want to take tissues, but egg cells can be preserved in some species if you develop specialist techniques for them. So like Stevie mentioned, we are working with Jimmy's farm. A PhD student is working on preserving eggs from butterflies. So some invertebrates we can potentially preserve the eggs from. Or also, as Lucy was starting to mention before, we can take ovarian tissue and then use some advanced cell culturing techniques to try and grow that tissue to mature the immature egg cells that are within that tissue. Anything else you'd like to add?
Yeah, I think also sometimes if we don't have the immediate avenues of utilising the resources at the minute, we still try and preserve them using best practice knowledge that's currently available to us, because some of these technologies might well come down later down the line. But if we don't start by preserving the resource initially, then we haven't got those resources for later down the line. So if there is one that is a little bit more technical or challenging, or there isn't current research available for it, we have a strong scientific committee behind us, which is an invaluable resource that we can call upon for their knowledge and expertise, and will very much be guided by that for best use of that resource.
I think maybe time for one or two more questions, and then we better wrapping it up.
Okay.
Is there any more, or are you all done, Alice?
We have just gotten one right in.
Yeah.
Can you remind us of the difference between a living biobank and a traditional biobank?
And that is so important, that, and I don't know whether, I can do it if you want. Yes.
I don't mind.
Yeah, go on, Debbie.
Yeah.
So I think I've done it, Lucy's done it, so I think it's this time, yeah.
Okay, so traditional biobank is when tissues are taken from animals and stored in a way that the DNA is preserved, but the cell that the DNA is contained within is non-functional. So as we were talking about before, if you put a cell or a tissue in the freezer, which is what biobanks are. They're frozen repositories. If you put that cell in the freezer without any cryoprotectant, the cell will rupture and it's non-functional, but the DNA inside is still useful for research and genomic analysis and informing conservation decisions potentially. So that's a traditional biobank. With us, with a living biobank, cryopreservation biobank, as we've mentioned, the cell remains intact because we apply or provide it with cryoprotectants, which, as the lay science person, likes to call antifreeze, because that's what makes sense to me. So we put different cryoprotectants for different species in those cells, and that's what the extraordinary science and the team here are so amazing at, figuring out which cryoprotectant is going to support that cell in liquid nitrogen at -196. So the cell remains functional, so you can use that cell as a living cell, which obviously still retains the DNA within it. So I hope that explains that.
Yeah, brilliant. All right.
We do have a couple more questions in, and I think they would be really nice.
Okay, go on. Yep.
So
we'll do short and sweet answers.
well, the last one's a bit open-ended, but I'll start with the easier one first, perhaps. So do we have a target list for species which may be very endangered but are not currently well represented in captivity?
That's a good one for you, Debbie, I think.
Maybe we can talk about our UK natives preservation priority list.
Yeah, so it's a really interesting one, because obviously there's so many animal species around and we want to protect them all, but there's just not enough time, resources, all of those kind of things. So people do like a priority list, and it's quite difficult to sort of narrow that down in that way. For exotic species, we try not to, because we are very much an ad hoc model. As you've already heard, it tends to be when an animal passes away. So we're quite lucky with what we get. So if it came to prioritizing certain species, maybe we might miss some of those opportunities, and we wouldn't want that either. In terms of our own prioritization work that we've just been doing recently, it's more in the sort of native species realm. We don't just want to look at exotic species across the world. We want to also focus here at home, because we've got so many species that are at risk of going extinct. So what we do really is what anyone else would do. You look at the best knowledge that's out there, and there's already fantastic work that's done from conservation scientists across the UK who have identified what are known as sort of BAP species, Biodiversity Action Plan species, and we've just followed suit with them and tried to hone our own list based on that research, actually.
And I think it's really important to add, thanks Ronnie, really well answered, but I think it's important to add that there's an awful lot of attention given to very charismatic species. You know, we all see the elephant and the rhino, of course we all care about them, but they get a lot of attention, and the focus seems to be there. Whereas for us, you know, we're taking the invertebrates, the slightly non-appealing creatures as well, because that is the entirety of an ecosystem we need, as I was saying before, from the smallest all the way up to the biggest. So we won't, we're inclusive.
That's right. Yeah. Quite often some of those tiny sort of forgotten species, they tend to be the ones that have the biggest impact on the ecosystem.
Yeah, that's right.
We've just gotten a little flurry of questions.
Because a lot of these we can answer them later.
I think I'll pick one more.
One more.
Yeah. I think that this is a great question. So somebody has written in from Mexico, asking, what would be your suggestion to get started with biobanking at a zoological institution?
I think the things that we get asked us a lot about our expertise, and I think one thing you've got to learn about now, Nature Safe, we're about knowledge transfer, we're about sharing our knowledge, about getting partners on board. We want to be inclusive with everything we do. So, and you don't, you know, in Mexico, I've been to Mexico. I went to the GGBN conference out in Mexico, which was absolutely incredible. You know, big biobanking conference out there. And you don't really want to reinvent the wheel. So it's coming to Nature Safe. Debbie's actually put a really amazing sort of PDF brochure together. Thank you for the word. I was searching for it there somewhere. And that explains what it costs, what the things you need. But obviously, we can help do the training as well. We've got a real expert panel. So, yeah, setting up a biobank, we can certainly email you that out to you, just to, so the basics that you need. Obviously, you need the partners on board. You've got to get the samples in and everything else. But we're here to help 100%. And we will, help in whatever way we can, trying to facilitate that.
And our contact details are on the contact page of our website. So if you want to shoot us an email to talk directly, then we can discuss it further with you.
Yeah.
Okay.
Brilliant. I think we've got a few closing things, but before that, we have a winner. So we have a winner tonight who's going to win some tickets.
Tickets to the Rhino evening.
Which
now, this has been picked at random, so I'm hoping you're in the UK, and I'm hoping you're not a million miles from Shropshire. Damien Kane, you are the winner of 2 tickets to our Rhino night on the 18th of February. So yeah, come on down and watch that documentary. 2 tickets on us.
Thank you. And the next one is a call to action. I think, Debbie, this was for you to talk about, wasn't it?
Yeah, so really, I mean, as you've heard now, the work that we do, and we are a charity, we rely solely on donations and philanthropic giving. So if you can help in any way financially, that's always amazing. Equally, if you have some spare time and feel like you have some skills that you could volunteer to us with, we're all ears as well. We are a very tiny team, so any help is always appreciated. If you head on to our website, there's a donate page, as I say, or just reach out on email, and we'll get back to you. Thank you.
Honestly, yes, obviously we want donations, there's no doubt about it, but there's so many other ways that you can help charities, isn't there? There really is. Opening doors. You may know somebody who wants to be part. You may be a corporate person. The corporate responsibility is really big now. We have a lot of corporates want to come on board. Obviously, this donation can help hopefully boost their profile of their company as well. They're giving a bit back. There's so many things we can do.
That's right. So we've got an ESG policy that we can feed into that.
So many ways
for businesses, but yeah.
So right, okay, Sarah, if we can stand up and just do this last bit. I don't know why I feel I've got to stand up. Yeah, just here. But just finishing off tonight, it's been an amazing night. But before we finish, we've got a film night. I think hopefully the slide will come up in a second. Is the slide up? Yeah. So the film is, well, maybe you can't see this because the slide's up. It's called Rhino. It's £20 to come in. You get some gourmet popcorn, whatever gourmet popcorn it is, but I'm looking forward to it. An pot of ice cream, ice cream, and a glass of prosecco. So what more do you want? And also see this incredible documentary that is narrated by Tom Hardy, and that is on the 18th of February here at Whitchurch in Shropshire, Chapelfield Stud. 7 o'clock in the evening. We've got red carpet, we've got flames, we've got the glitz, the glamour, and everything else. Wow, we have got some fun. We'll get a life-size cutout of him and we can put him up there. So thank you for that. The next slide is about the skydive. If you want to come and do a jump, we've got the poll question. We really would love for you to come and have a bit of fun here. And jump out of a plane at 13,000 feet. 1 minute of free fall doing 120 mile an hour. What more would you want to do? And at the same time, you can raise money to save species. To me, that's one of the best ways of raising money. Donate here. I think there may be another slide coming up.
Donate.
Brilliant. We have a stakeholders day, Gronya, don't we? Tell us a little bit about that.
Yeah, so that's on the same day as the Rhino film screening, which is on in the evening. The stakeholder day is really primarily for any of our conservation partners or anyone that might be interested from other animal collections. It's all to do with captive breeding programs and how we can help. So the work that you've heard from tonight from Pam and also Kit will be featuring quite a lot of that kind of stuff. So if you've got a managed breeding program, want to hear more about that, that's the day for you.
Right, well, that's drawing to a close now, and honestly, wow, what a night. To me, it's been incredible, and we have an amazing team, and teamwork says dream work, and it really is in this instance. So just going through all the people now. Behind the camera, we have Sarah. So honestly, yeah, had a very steady hand. We've got Debbie Romanus here, Gronya as well, Lucy, Alice. I'm quite good at remember these names. I'm not knowing Matt, Alice, and Alice, Pam, and so nearly right. How many years have you been with us, Pam? Yeah, thank you. Oh, that's who it is. We got Lucy Node, and also downstairs we have Lydia and Lauren. Yes, I've got that. I think I've got everyone on the list. Oh, Kit and Stevie. How can I forget Kit and Stevie? So, I mean, what a team. I don't know how many of us, 15 of us or something. There's a, and, you know, there's a lot of work. But more importantly, thank you for joining us. We couldn't do this without you. We really couldn't. And we really, really appreciate you joining us tonight and showing off, I believe, what is the most amazing charity that Nature Saver is. And you can see it behind the scenes. And again, if you want to learn any more, please look at the website. And we'll look forward to seeing you soon. Thank you again. Good night.
Bye.
Bye. Bye.